Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily Challenge raw and uncut. So let's get started. So today's question is a medium. It's called minimum operations to exceed threshold value 2. You're given a zero index integer array num. So the input is an array of numbers and um, an integer. In one operation, you will take the two smallest integers, x and y, and you remove that, and you want to add the minimum, um, the minimum of x and y and the maximum of that, but you want to multiply the minimum by 2. Note that you can only apply the described operation if numbers contains at least two elements. So return the minimum number of operations needed so that all elements of the array are greater than or equal to k. Right, but well, when I first read, like when I first read this, I think like doesn't this just force that like you take the smallest integers? Uh, yeah. So this is like what I'm a bit confused about. So like for the minimum number of operations, I think like we just keep looping until until we get we get all the numbers to be k or bigger. So what do we need? We need sorted list, right? Um so actually if we do it in C++, we can just do ordered set, and like that will automatically sort all the numbers, and we can also get the smallest number as well. Yeah. But let's do it in Python. I think C++ would be a lot easier to do for this one. But yeah, let's look at the range as well. So like let's look at the constraints. So the array would be 10 to the power of 5. Well, like it would be 200k. The numbers, they're just like any int32 numbers. K is also just any int32 numbers. Well, less than that. It will be a billion. The input is generated so that an answer always exists. So that means like we won't have a case where like the whole array is just full of ones, and then k is like a billion and we can never reach there. And also the number of operations that we have to do, if you think about it, every time we take the two numbers, what will happen? Every time we take the two numbers, we are just gonna like we are turning those two numbers into one number, right? So if we have 200,000 numbers, we at most have to do one like it would be like around 200,000. Well, I think it's 200,000 minus 1 because you have one element left at the end. But so that means every time when we do the array, if we can just find like an O log n solution, it will work. So we need some ways to remove the two smallest elements, and then we need to add the we need to add the um like the new element in, and then we want to we basically want to take the smallest two, like the two smallest element, and then add the new element in log n time. When I first read the question, I talked about sorted list, right? I think sorted list would work because if I'm not wrong, it allows insertion for log n time, and it also allows deletion in log n time. But actually, we don't need that. We can use a heap. So, what I mean is, let's draw out the example, right? So we have 2, 11, 10, 1, 3, So if we have a heap, we can guarantee that we can get the smallest number. We don't actually know the ordering of the heap array, but we can get the smallest number. Like so we guarantee that like 1 is going to be at the beginning, and then after we pop 1, we are guaranteed that the smallest number of the remaining number is going to be the smallest. So if we do that, we can pop the 2 smallest elements in log n time, and then it also allows log n insertion for heap. So yeah, so that would be the solution. I'll just draw a bit out, I guess. So after we get 1 and 2, we use the formula. So we will have 1 times 2 plus 2, so that will be 4. Does that align with... Yeah, so that aligns with the explanation that we have here. So we pop 4 in here, so we will have what, like 11, 10, 4, 3. And again, we are guaranteed that the smallest element is at the front, so we can just do that. And then and after we get rid of 3, 4 is going to be at the front because it is the smallest. And we can do the formula again. So we'll have 10 there. So so after 2 operations, the smallest element we get, is 10. If the smallest element is 10, that means the whole array is either like the whole array after 2 operations would be either 10 or greater. So we have met the requirement we need, and we can just return that number. Yeah. So let's just start coding. So first of all, we want to import heap queue. And then for Python, it automatically, like when we initialize a heap, it is initialized as a min heap, so we don't even have to do any tricks on this. Actually, I want to talk about like what happens if you need a max heap. One really neat trick you can do is that you can just negate every number. So if you have like 1, 2, 3, 4, you can make it like -1, -2, -3, -4. Well, because it is a min heap, it is going to give you -4, right? But then you just negate that again, so you'll get 4, which is the biggest element of like the array 1, 2, 3, 4. Yeah, it's just a bit of a sidetrack, but let's get coding. So we want to form a heap. So that will be heap queue heapify. I think it's called heapify nums. And then we can have operations. So equals 0. So while true, we're guaranteed that we are going to arrive at a solution. So we can just loop through this indefinitely until we get the solution. So we want to check if heap 0. So if the first element, we're guaranteed that the first element is the smallest, right? So if the first element is greater or equal to k, then the whole array is already greater than k. So you can just return number of operations. Otherwise, we do want to do one operation, right? So what do we want to do? We want to get a and b. So we will do heap queue, heap pop. We will pop from the heap, obviously. And what is the second thing? We want to pop from it again. And if I'm not wrong, Python will do this first. Like, we will do the first one first, and then we will do the second one. So we'll get the 2 numbers that we want. And then what do we want to do? We want to push in, like, according to the formula here, right? So we have heap, and then we have a times 2 plus b. Why do I need to do like the min and max? We are guaranteed that the first element is always, like, the first element is never bigger than the second element, right? If not, it will have come first when we do heap pop. So yeah. And I think that should be the solution. Let's see. None type is not subscriptable. Huh. So why is it none? Heapify. I think I just do nums actually. Yeah, nums. So when we heapify, I'm pretty sure you're heapifying like in place. So you're actually like just doing nums. Like you're turning nums into a heap basically. Yeah, so now it works. Well, this, like if I do it this way, it is going to affect the purity of the function. So what that means is like I am modifying the input, which technically like is not good, but um well, the better way is probably to do something uh like heap equals I think like nums copy, or like copy nums or something like that, like to basically copy, like make a copy so we don't affect the original input. But yeah, well, that's the solution. So yeah, I'll see you tomorrow. Bye.